to this video where there is a demo of how the Tic-Tac-Toe smart contract actually works. So as you can see, there are two screens. One screen has the Tic-Tac-Toe game that I'll be playing, and then I'll be showing you that how the smart contract actually functions and plays the game. So as you can see, I've created a contract in Sophia. The contract name is Tic-Tac-Toe. I'll be deploying the contract now. You can see in the tutorial as to how you can create your own contract, but I'm just going to show you how the contract works as of now. You can see that the contract is deployed. The first thing that we need to do is register a player. We need to give a player name and the address. So as you can see at the bottom left corner, I have noted two test addresses, and I'll be using them to test out the contract. One of the addresses is player 1 and the other address is going to be my player 2. Now I've registered the first player 1, that is Gyan, with the address. So this address would ideally be the superhero wallet address. So the players can also play for tokens and have fun. So I'm going to be registering another player named Carlos, and I'll be copy pasting the second address over here, and I sent the transaction to the contract, and the second player is registered as well, as you can see, with the player ID as well as the player name is Carlos. Now the next function is initializing the game. This would ideally initialize this board, tic-tac-toe board, for you. Now what does it mean by initializing this tic-tac-toe board? Each of these squares are numbered. So if you start from the top left, it's number 1, and then the next adjacent right square is number 2, the next adjacent square is number 3. So you have 1 2 3 4 5 6 7 8 9. So the moves that the players make are mapped in the form of square versus moves, right? That's how we have created the mapping in the contract. Now what I'm going to do is, next I have created a game, right? So I've created a board. Now I need to assign the players to the game. So I'm going to be assigning two players, the same two players who are registered as players to play any tic-tac-toe game right now in our system, right? So I'm going to be registering one address as well as the other address, Gyan and Carlos. Once we send this transaction, these two players will get added to the contract, to the game, sorry. So you see game ID is 1, the game is not completed yet, and you can see there's a player 1 ID and player 2 ID. Now is when we actually start playing the game. What I'm going to be doing is, there is a function called make move, which will which will change as we keep making the moves and keep updating the game data. So here is the interesting part. I'm going to be sending values to the make move function as per the gameplay that I'm going to be playing over here in this screen on my left. So on my left you'll be seeing me playing the game, and on my right you'll see that I'll be sending the same values to the smart contract and make the moves in the Sophia language. So player 2 is making a move, player 1 makes a move which is square 1. So as you can see, there is a cross on square 1, right? And now player 2 makes a move which is copy pasting the second address, and so the first one is the game ID. So game ID is number 1, and then the player address and what is the square that the player wants to move. So player 2 now has moved to square 5. So you can see I'm sending 1 address and 5. So player 1, so 1 comma 1, that means square 1 has been occupied by player 1. Square 5 has been occupied by player 2, and so on. So as you see, as the game progresses, I'm just going to show you one more move and then move forward. So if you see, again it's player 1's turn. Player 1 wants to now occupy probably square 1 2 3 4, right? So I'm going to be sending one game ID. In this game, for this player wants to make a move 4 to 4. So you can see that it will be 4 comma 1, that is the fourth square is occupied by player 1. And as both the players keep making their moves on the board, you can see that the game moves keep getting updated. 1 comma 1, that is square 1 occupied by player 1, square 3 occupied by player 1, and so on, right? So when the game is about to come to completion, what happens is we need to call a function called check the status of the board right now. So the game is still going on. As you can see, some moves are being made. Now the last move here would be by player 1, that is Gyan. If she makes the move to the second square, then player 1 wins, that is Gyan wins, right? So currently we have written a function where we call this entry point called board check with the game ID. It checks the status of the board and the game and returns the winner if the game is completed. If the game is in progress, it returns a value called in progress. So now that I have made in the contract the move for this second square by player 1 has actually won, right? So let's see what the game returns. So the game, our smart contract should ideally return Gyan because Gyan is the winner. Let's see what the smart contract returns. Yes, so the return value of the smart contract is Gyan. Gyan is the first player in the as registered. She is the first player with player 1 ID belonging to Gyan's address, and she has won, right? And this is the winning pattern, that is 1 2 3 has been occupied by player 1. Therefore, she is the winner, right? This is how your smart contract would work. This is a very interesting and fun smart contract, and if you're able to add some front end to it, you can definitely make it very interesting. You can also play for AE tokens. Winner sends couple of the loser sends couple of AE tokens to the winner, etc., and have fun, right? This is a fun way to learn how to write smart contracts, and I would encourage you to go through this tutorial, the following tutorial, to understand how you can write your own smart contract in Sophia smart contract language to code this kind of fun game.